Hello students, welcome in our PMI chapter, Principle of Mathematical Induction. In the last exercise, fourth numerical. Yes students, in the fourth exercise, I am going to question number 23. Prove that by PMI, 41 raised to n minus 14 raised to n is a multiple of 27. Yes students, what the meaning for multiple? Yes, they must be 27 table, 27 ones are, 27 twos are, 27 threes are, just like any number, but must be multiple of 23. So I going here, our step 1 by PMI means first step, if n is equal to 1. If n equal to 1, then you can write down P of n, 41 raised to n minus 14 raised to n. You don't write down LHS, RHS. Here P1, 41 raised to 1 minus 14 raised to 1. How much? Definitely 27. And sure, yes, it is what? Multiple of 27 is first. So, I just say P1 is true. Continue. Now step 2. My step 2 is if Pk is true. Yes students. Now what is the P of k? This full equation again, right? 41 raised to k, 14 raised to k is multiple of 27. You know what the again I asking multiple of 27? Which have to you write down must be, that is 27 into some multiply number. I just write down n for k and m belongs to natural. Yes students, here your k and m belongs to natural. Now step 3, to prove which have to P of k plus 1. Only k I change in k plus 1. So 14 to the power k plus 1, 14 to the power k plus 1 is multiple of 27. And this I start now, very easily I prove. So for only I am explaining 41 to the power k plus 1 minus 14 to the power k plus 1 is equal to, can we write down power changing in the k term and in the 1 term, same k and 1. Now look at that here students, 14 raised to k, 41 raised to k and here 41 raised to k, both of the convert this value, put down here. Either 14 raised to k also correct, then you carry forward here. Now 41 raised to k value is indirectly 27m plus 14 raised to k into 41. This value I carry forward right side, plus 14 raised to k and minus 14 raised to k, 14 same, because Pk is true. By step 2. Now students, you nothing do, 27 into m plus 14 raised to k multiply with 41, is here 41 multiply and here 41 multiply, and minus 14 raised to k into 41. Now students, look at that, here common, you must be have to common. So 27 into 41 into m. And what is the common? Yes, you correct think about that. It is a 14 to the power k common. 41 minus 14. And which have to? Yes, that is your 27. So 14 raised to k. Now 27, you just take out common outside. So I have only 27 common, 41m plus 14 raised to k, but it is nothing. I just take out something t, and here show as assume that 41m 14 raised to k is equal to t for k and m belongs to natural. So t is also natural. Natural number, no? Then multiply 27. So yes, it is what target achieved. It is multiple of 27. And after that, students, you just write down these two lines. Already know these two lines, but I just only write the formality wise. After that, you return the below that. Therefore, P of k plus 1 is true. And if Pk is true, then P of k plus 1 is also true. And last, write down by PMI. This Pn is true for every n belongs to natural number. Yes, students, one more time I explain you. These are the main steps. That's why I highlight in red color. 41 raised to k, converting in the here 41 raised to k. Either 41 raised to k also you converted and then put down there. Any number you use, definitely you get the correct answer at the end of 27 multiple. T is not a considered some value, it is a multiple number because the any number of the natural. Yes, students, here our this question 23 happily done. Now I going ahead 24. Yes. Now students, after ending 23, I go ahead 24. Exercise last numerical. Prove that for every n belongs to natural number, here less than, which is inequality, and less than proving. So that's why this question is, students, you pick mark in the most IMP numerical. Okay? Yes. Already I explained you one inequality related questions. This also inequality. Yes. Now I am going ahead. Don't write down LHS, RHS. Only going to putting the value both sides. So if our step 1, what is step 1? If n is equal to 1, put down in the Pn 2n plus 7 less than, same as I only just putting there n is what? 1. Again saying don't write down LHS, RHS because you are not given equal. It is unequal. I mean less, greater, greater. So what you getting? 2 into 1 plus 7 and 1 plus 3. So my answer is P1. Here 9. Here 4, 16. And 9 less than 16 is true. Therefore, P1 is true. Students, this is the main step. So, now step 2. If Pk is true, and that's very easy. P of k, you just show down that 2k plus 7 less than k plus 3 whole square. K belongs to natural. And now step 3, which is to prove. Students, change. This is the last question this exercise. Every numerical I explain by step 1, step 2, step 3. Method same. Correct, no? Yes. Okay. So step 3 to prove P of k plus 1. Here, just only change I to k plus 1 plus 7 less than k plus 1 plus 3 square. Indirectly, just I write down there k plus 4 the whole square, and that's my target. Yes, students, target to be must be clear. What you get? K plus 4 whole square using this. So now I start for 2 times k plus 1 plus 7 is equal to, same I write down 2k plus 2 plus 7, but I know that this is step 2, 2k plus 7, so I then write down 2k pk plus 7 plus 2 separate, and here same as plus 7. Now students, this value I just in place of that write down that less than this. So here less than, because this less than, and k plus 3 whole square same, and here also k plus 1 plus 7 same is, because here write down pk is true, and that value I just going to that after simplifying. Check, this answer equal to that. Our target is achieved? No, but I am going that 2 of k plus 1 plus 7 less than k plus 3 plus 2, and listen here, this is a main turning point. This answer already not coming there. I just write down k plus 4 whole square and check it is true or not. First of all, I prove this is true. Anyhow, but using this step to natural number. So here I am now explaining why it is true for the legal step and why I write down here this. I think you students think about why sir is written here k plus 4 whole square, because I prove that this already written, but now explain it is why written, it is why true. So k square 6k 9, k square 8k 16, just expand it. So k square 6k 9 plus 2 minus k square minus 8k minus 16 less than 0. This cutting down 6k minus 8k minus 2k, 9 into 11, 11 minus 16 minus 5. Now students, minus multiply both sides. Both sides, yes. So, you know rule for minus multiply both sides, then inequality change. 2k plus 5 greater than 0. Here minus minus change, less than changing greater than, and 0 multiply minus is 0. This is true for every k belongs to natural. Check. Already no new step 2, it is true. Check, every natural number apply here. Just like a 1. You getting 7 more than 0. 2, then 4 plus 5, 9 more than 0, true. It means this data is true. It means this statement is true. It means this statement is also true. So last I write down therefore 2 times k plus 1 plus 7 is less than k plus 3 whole square plus 2 less than k plus 4 is whole square true. Therefore last statement here I write down. Therefore 2 times k plus 1 plus 7 is less than k plus 4 whole square is true. Yes students, after that you can write down this one, and actually this proving is now done here. So last write down, so p of k plus 1 is true, and last if pk is true, yes, then p of k plus 1 is also true. Students, I here written small words, but don't worry, you understand that. Main step is this. And again repeat, what to do here? This equal to that already I come in there. But this answer actually you proving this in step 3. That's why I written. And why written? Explain this one. By the true possibility. And if you do that, it means this data is true. It means this data is true. So we kind of have written last answer. And here student is happily done here. Now your exercise over. Now I go to illustration. Example. Now students, I am going to examples after exercise over. Students, in the examples, there are different variation type questions. That's why I explain at the ending of this chapter. And exercise first I explain you because it is a parallel numerical. Then you easily flowing wise you understood. Now example 1. Prove that for n greater than or equal to 1. The 1 square, 2 square, 3 square, 4 square, n square is equal to means you prove LHS is equal to RHS and n plus 1 2n plus 1 by 6. So very easy numerical. Step 1. If n is equal to 1, here I just write LHS. And this first step I just take down 1 square 1 and RHS. That RHS n plus 1 2n plus 1 by 6. And here students, n is taking the values of 1. So here n is 1, 1 plus 1, 2 plus 1, it just like 1, 2, 3, surely. So LHS is equal to RHS. It means what? P1 is true. Now step 2. If PK is true, students here PK forming, I just going whole equation n converting into P of k. Yes. So n write down in the terms of k. 1 square, 2 square, 3 square, k square is equal to k plus 1 to k plus 1 by 6 for every k belongs to natural. Now step 3, which is to prove. What is to prove? P of k plus 1. So we have to, this statement I just translate k value in terms of k plus 1. So here just I going to 1 square, 2 square, 3 square and k plus 1 whole square. So here how many values? K plus 1, k plus 2, 2 with the k plus 1, plus 1 by 6. Indirectly here, actually you can get it. The value is 2k plus 3 by 6. That's my target. Now I start easily LHS. So my LHS is 1 square, 2 square, 3 square, k plus 1 whole square. And what the 1 reverse term? 1 square, 2 square, 3 square. Here k square, but here k plus 1 the whole square. Now students, this value actually 1 square to k square, which is known. These are. Step 2, put in there and easily over the numerical. So this value actually put down there here. K plus 1 to k plus 1 by 6. This value here. And k plus 1 as it is. And declare that because pk is true. And that's the our now common taking. So what is the common? K plus 1 common. Remaining is a k to k plus 1 by 6. And here only k plus 1. Students, now you simplify taking LCM. So k plus 1 same as here 2k square plus 6k plus by 6. I hope you understood. Simple our taking the splitting. 2k square 7k by 6. Now students, 6 2s are how much? 12. But I want 7. 4 3s are. So k plus 1. 2k square. 4k plus 3k. Yes. By 6. 4 3s are 12. And both addition, it must be 7. Now common take. It have 2k common. K plus 2 plus 3 comma k plus 2, and last k plus 1, k plus 2, 2k plus 3 by 6, and this value is your RHS. Look at that. This is your RHS now. Already I written there, and this RHS you just ended here. So I just write down is equal to RHS. So P of k plus 1 is true, and last after that, therefore if Pk is true, then P of k plus 1 is true. And here students, our this question is also very happily over. And last line, to write down itself, I not written here, but you write down itself in your notebook. By PMI, this Pn is true for every and belongs to natural number. Yes students, here our this numerical is done. Now we going ahead, example number 2. Now students, I going ahead, example 2. Same pattern, inequality given. So prove that 2 raised to n greater than n for all positive integer. You know students, meaning for positive integer, it is natural number. So I just start here our P of n, which is 2 raised to n more than n for all positive integer, means n belongs to z positive. Either you also write down n for natural number. This also true, no students. Anyone you write down. Z positive is entirely natural. Both meaning here you same consider. So I am going only natural. So now step 1. Step 1, if n is equal to 1, students, you never write down LHS and RHS. Only going to our data, putting n is equal to 1. So my P of n, which have to 2 raised to n more than P of 1. So 2 raised to 1 more than 1. And what is 2 more than 1? Yes, it is true. So I just write down P1 is true. Now step 2. What is step 2? If Pk is true. Students, your given data, you just apply in terms of k, that is your n. I just write down in k. So 2 raised to k more than k for every positive integer. So here write down every k belongs to n. Now step 3. Step 3 is also easy to prove, which have to P of k plus 1. Students, this k I just write down k plus 1. So 2 raised to k plus 1 more than your k plus 1. That's my proofing. Now I start 1 by 1. 2 raised to k plus 1. Just convert in terms of here. This term, students. Step 2, I implies that P of 2 raised to k. So here I just dissolving in the two terms. 2 raised to k, 2 raised to 1. And look at that. These are same as to that value. And it is what? Greater than k. So here greater than k. Here 2 same. Because Pk is true. And here same as 2 raised to our k plus 1. Now that are same as 2 raised to k plus 1 more than 2k. Check, it is equal to proving your answer? No. So I going to checking here k plus 1 write down. And why it is write down, that I prove here. Same numerical I explain you, exercise last numerical 24 students. Let's same here. If you not getting direct answer in proving, you put in that value and prove that indirectly it is true. So here for I checking 2k is more than k plus 1. check it is true. K more than 1 is correct for every positive integer. Yes, it is true. So for every positive integer, value of k is true for k more than 1. Yes, more than 1 going 2, 3, 4, 5. It is true for every positive. It means this statement is true. It means this is true. It means that also true. So finally I write down 2 raised to k plus 1. More than 2k. More than k plus 1 is also true. That's why students, I just write down 2 raised to k plus 1. These are greater than k plus 1. I think you know that this formality 5 more than 4 more than 3 more than 2. No. You take out that 5 more than 3. Either 5 more than 2. True. Same concept here I am applying. Okay. So therefore P of k plus 1 is also true. And students, here check. That's your destination over. But you must be right here and prove that my statement is true. So, therefore, if Pk is true, then P of k plus 1 is also true. Now, finally, by PMI, principle of mathematical induction, Pn is true for every n belongs to our positive integer, students. Yes, students, here our this question example to done. One more time I explain you. Only this point is main point. P1 is true indirectly I am taking 1. But P of k true. Then necessarily write down 2 raised to k more than k for every k belongs to n. It is given and I prove that k change k plus 1. So here k plus 1 and then I start. And must be 2 raised to k convert in the terms of m. So 2 raised to k and 2 raised to 1. Now to k, this value is greater than k. From step 2, pk is true already I written there. And this to data number. And this value why I written? Because that's my proofing. And after writing, these two are proved for true according to given positive integer value of k, and then after I return this, that and these are true. So final return 2 raised to k plus 1 is more than k plus 1, and last to write down pk plus 1 is also true. And lastly by PMI as well as you know that Pn is true. Yes students, here our question 2 and this part is also finished here students. Further explanation for third example, 8th example I explain you in the last part of this chapter. Okay students, bye bye, see you.